Okay, everybody, this is where almost everything that we have covered thus far in this video series comes together. I'm assuming that you have your Docker for Windows fully operational on your Windows machine. And I'm also assuming that you have successfully deployed the test automation that I have shared with you as part of the downloads for this video to your orchestrator tenant, right? And assuming that you have completed these steps, we are ready to create our first UiPath Docker container. In the opening section of my previous video, I had said that the Academy course assumes that you already know how to set up the Docker image and also how to create a Docker container, right? And therefore, if you go through that course, you will find that it does not touch upon the very first step of pulling a Docker image, right? Instead, it dives directly into the process of running your Docker container. And if you are new to Docker and you start with the course directly, there's nothing wrong with the course. The course assumes that you know all of this, right? And if you are not familiar with Docker, you will miss this step. And with that, let's get into the first step in our deployment process. And that is to pull the published image for the UiPath Docker container at UiPath's Docker registry. So what we do next is we copy this URL, and then we go back to our command prompt and we run this command. I'm not going to run this because I already have, and I'm going to spare you the agony of watching this thing install itself on my machine. Instead, I'm going to show you what to expect. So once you hit run on this command, this is how the output is going to appear. There are many number of components that are going to be installed in parallel as part of pulling this image down. And they can take anywhere from 45 seconds to almost 2 minutes, depending on your operational situation. And once the installation is done, you will see this message at the bottom. It says that the latest version that has been published by UiPath has been installed on your machine. And once this installation step is successfully completed, if you jump back into Docker and navigate to images, you will see your image listed here. Now, in your case, it might not show the in-use flag. That is because you still haven't created any containers yet. But I have already created the containers, and therefore the image that you see here on my machine is flagged with an in-use label, right? So this is what it takes for you as the first step to pull the UiPath published Docker container image. The next step for us is to create a container out of the image that we have downloaded. This is a pretty long command. So what I'm going to do is I'm going to copy this and I'm going to split this into multiple lines. And if you have watched the previous sections of this video, the Docker run command must already be familiar to you. And the first parameter that you need to pass to Docker is the license agreement. Remember, this is an input argument required by the Docker image, right? And this is the image that you downloaded. The next line is your orchestrator URL. And from the previous step in this video, you will need this orchestrator URL. And the other item that you will need after you set up your machine template in the earlier step is the machine key, right? And what you will do is you will substitute your orchestrator URL and your machine key here. And then to execute this command, you would want to run this as a single line. And you go back into your command line. And when you hit run, a Docker container will be created for you on your Docker installation. And if you have successfully executed this command and you come back to your Docker installation and look at the containers, you will see a Docker container with a funny name. And as we discussed about at the beginning of this video, you're going to most likely rename that container to make it look more meaningful. Now, in my case, I've already run the Docker run command, and I already have a container running, and I have already renamed it to YouTube demo 1. And I will be starting this container, but remember, in your case, you are going to be running this Docker run command, waiting for your container to be created. Your container will have a funny name, and you will use the Docker rename command that we discussed at the beginning of this video to rename your Docker container to something meaningful, right? So I am going to remove this command. I don't need this. Instead, I'm going to run my Docker listing command. The next step for me is to start my Docker container. Docker start, and my container name is YouTube demo _1. Very good. My container is started. And if I come back, you will see that my container is running. I'm going to click somewhere in the middle of this bar here. The logs are pretty exhaustive. And if you have specified your URL, your service URL, your machine key correctly, then you will see a message saying that there is a heartbeat that is being established between your Docker container here and your UiPath orchestrator tenant, right? And that shows you have successfully connected from your Docker container to your orchestrator, right? In essence, what you have done is you have deployed your first UiPath Linux robot. There is a very important thing that you have to note here, and that is the container ID. I had said that we are going to be coming back to it in the earlier part of this video. So if I go back to the command prompt and run my listing command again, I'm going to run it again. And here is the UiPath container that is running. And you will see that its runtime status is it's been up now for 2 minutes, right? And here is the container ID. I'm going to copy this container ID and I'm going to put it in my notepad. I don't need this command here. And I'll go back to my orchestrator instance and I will go to the tenant level, go into unattended sessions. And here you will see one connected session amongst the many. And if you observe the host name, that host name will match your container ID. So if I copy this and go back into Notepad and paste that here, you will see that these two IDs are identical, except that Docker deals with all lowercase container IDs. And what you see in the UiPath tenant is all uppercase. And therefore, you can see how useful that this container ID is and what its significance is as far as establishing connections from your Docker containers to your UiPath orchestrator tenant. We are going to now inspect this container and see what information it has for us. To begin with, you will see that your meaningful name is displayed here along with the source of the image and the status of, obviously it is running. And if you go into inspect, notice that these are the same input arguments that you specified when you executed the Docker run command. The first is, of course, the license agreement. The second is your orchestrator URL. And the third is the machine key. And then what is important here is .NET running in container, right? Is .NET running inside the container? And it is set to true, right? And this is what makes your cross-platform Linux automations run inside of a Linux container, right? And then if you look at the .NET version, it is .NET version 5. This is very important because we are going to cover this at the end of the video, but make it a point to note which version of .NET you're running, right? In this case, this official released version of the UiPath Docker image supports the .NET version 5. The next step for us is to run our automation. But before we do that, there is something really important that I would like to spend some time on. And believe me, I learned this the hard way. And I would like to share that with you so that you do not run into this problem. A few weeks ago, I had released a video on UiPath robot service accounts, right? And if you have watched that video, you will recognize that I'm connected to the same tenant that I used for that video. But it makes sense because this tenant is used predominantly to run unattended and or background service automations. That is what this tenant is used for. So at the time, if you recall, we set up a machine template there and we connected from our service machine using the machine key for the template. So what happened is when I started setting up my Linux automation infrastructure, my service machine was already connected to this instance of the orchestrator and the machine key that I used to connect to that template, right? It was already consuming the unattended license, right? And this is very, very important as far as UiPath community users are concerned. Community users have just one unattended bot license. You might have 1,000 templates, but you still have one unattended robot license, right? So here's what happened. I came back to this instance. I set up all my Linux automations. And when I started running them, all those automations started going into pending state. And it did not cross my mind that my service robot on that service machine was connected, right? And obviously I could not see it because that machine is remote. And if I have to connect from that machine, I have to remote into that machine and then connect or disconnect my robot from within that remote session. So I could not see it from my laptop. And every time I ran my Linux automation, it started going into a pending state. Now, here's the problem. If your Windows service robot machine template is a person and your Linux template that you've created in this video is a person, and these two persons go to the same gym where there is only one treadmill, right? The problem is the Windows automation template is constantly using that treadmill without allowing the Linux automation guy to use that treadmill. So what was happening is that that machine was always connected because it uses a machine key. And you know what happens when you connect using a machine key? The license is constantly consumed. Your license is tied up, right? And as long as that service robot was connected from my remote machine, the Linux automations were simply waiting in line. They simply could not use the treadmill. So I found that out the hard way. And finally, when I came to this tenant here, and when I got into this unattended sessions just to check what might be wrong, I found that my other remote machine was connected. And that's when it struck me that I might be having trouble with my unattended license, right? So as soon as I realized that, I remoted into that machine, I disconnected my robot from that machine. And as soon as I did that, all my Linux automation started running, right? So please do make a note of this because it can save you a lot of time. And I literally tore my hair out trying to think what might be wrong. Please make sure to come to unattended sessions to take a look at if any one of your unattended robots is tied up, because if you're a community user and you have only one license, you can run into the same problem as I have. But if you want to totally avoid this situation, use a completely different tenant. So once you squared all of that out, right, And if you come to your unattended sessions in your orchestrator, you must find your Linux host connected using the Linux template. Remember, it is important here. The template is important because you have set up this template as cross-platform only, right? So make sure that your container ID and your template lines up and you are in connected state. And if you have reached this point, that means you are now ready to run your first Linux automation. Coming back to the Linux automations folder, going into the package feed, I have the demo Linux file operation package already deployed. And then I've created a process out of it. Remember, there's nothing different here. Just because it's a cross-platform package, the setup to create a process out of the package is not going to be different. It's going to be the same. So I'm going to skip that step. And if I come back to processes, I have created a process named demo Linux file operation. And if I look at the details of that process, we have these arguments here. Now you can override the arguments here, or you can do it when you run this process as a job. So let's do that. Let's run our process as a job, and then we'll override the arguments to make sure that this is the process that actually ran during this demonstration, right? So let's cancel this out. And I'm going to start this automation. Remember, this is unattended, and therefore I can start this from the orchestrator. So I say start job, and here is the arguments. And I'm going to override the Linux file name. And here is the overridden parameter. And then I'm going to override the text as well. And then I'm going to hit start. I go to jobs. The job is running. Now, in your case, when you're doing this for the first time, you will see a lot of activity happening in your logs interface. And a huge number of lines are going to be written to this box here, and almost like 400 to 500 lines. And that is because everything that is required for your Linux automation to run will be created for the first time. And we can go through the logs in the next section. But here, there is a line, and you can see that the demo Linux file operation finished with succeeded, right? And sure enough, if I go back, you will see that this has succeeded. And I go to the logs, and here is the step that actually confirms that the file exists. And here is the path it has created the file in. And this is the path, the default file path that I gave to this process. And here you see we did pass in this as the file name. And obviously the placeholder has been replaced with the date. Now, how do we look for this file, right? Remember, this is written inside your container, right? So how do we do that? And going back to our previous section from our Docker basics, you click on the command line interface. Now you are in YouTube demo 1 container, and the file has been written to this container. So you hit the command line interface on this container. Okay, so what I do now is I'm going to say cd, change directory. And here it is. I have changed my directory. And to prove that, I'm going to say print working directory. Sure enough, I'm in that directory. Now, if I say ls -l, and here is the file, YouTube demo.txt. And if I want to check the contents of the file, I'm going to say cat. And there it is. This is the same line that we actually provided to this automation when we executed the job from the UiPath orchestrator. the automation also writes an additional step that shows you what the file path is, right? So this proves that we have successfully executed a cross-platform Linux automation inside of our UiPath Docker container. Now, when you executed this automation, you use this command line, right? You use the command line from your UiPath documentation, right? And this format of the running the automation is the non-persistent form of running your Docker containers. You can see that this is a very simple command line. It has the base minimum attributes that are required for it to execute. And this is the non-persistent way of running Docker containers. And that is because if you go back to these logs will not last after you shut down your Docker container, right? They will not persist. And that's why I'm saying this is a non-persistent way of running Docker containers. The only way to save your logs before you shut down your container is to go to the bottom right here and copy the entire stream of logs or take a snapshot at that moment, right? And that's precisely what I did when I executed my first Linux automation. And I saved that log and I broke it up into different sections just to see what's going on. And here is the log that I captured when I executed the first Linux automation. And I wanted to see what's going on here. And what I did is I scrolled the several hundred lines. There are close to 1029 lines. And I broke them up into different sections here. And if you look at the logs for the first time, here's what's happening. It is going to look for certain packages that are required. And if it does not exist, then what happens is it will start looking for those packages by ID by going to that URL of the repository, right? And you will see that run for several tens or even hundreds of lines. And you can see that it is looking for a certain package. And if it finds out that that package does not exist, it is going to pull it from the packages feed, right? And we go down all the way. The next section is after you passed all of this part where you will see a message that says resolving conflicts for .NET 5. After all those conflicts have been resolved, the next section is actually where the Docker container startup is happening, where the local package cache is being created. And here you will see that the packages are being installed, and you will see repeated messages of locks being acquired for the installation of a certain package, right? And there are many number of packages, and those messages are pretty standard and consistent in nature. And they will go down for several hundred lines. And then the next part of the logs will be to download the automation package from your UiPath orchestrator feed into your Docker container, right? And that is what this is saying. Of course, I had run a different package then, but you see what's happening. It is installing the package. It's acquiring a lock to install your package. And it is also acquiring locks to install rest of the activities that it requires to run this package. And of course, you recognize these activities. They're part of your package manager in the studio project. You have the system activities, you have the API activities, right? And once that is done, it will install the package into your container, right? And again, you will see many number of locks being acquired and the installations happening, and all of the packages that you require to be installed will be installed in your container, right? And then this package is built using VB and Visual Basic. And here you have Visual Basic being installed as well. that is installing Microsoft Visual Basic 10.3, and then all of the other packages that are required for the entire UiPath infrastructure to execute on this container. And once you're past all of that, finally, almost after 900 lines, your package is ready to be executed, right? Your automation is getting ready to be executed. And that is why when you run your first automation, you have to wait for a while, because you will see all of these logs streaming on your Docker console here. Then your package now changes status from preparation to execution. And then finally, your job is executing. Remember, the logs are being actually conveyed to your orchestrator, and you will see a lot of log messages exchanged and responses being received. And finally, when your job completes execution successfully, you will see a bunch of logs that reflect the functionality of your automation. Of course, this section is different because it depends on what automation you're executing. And once it has been successfully executed, you will see that the automation has exited with success code. And after the execution is complete, the container returns back to its normal state, or your stable status, where it keeps establishing the heartbeat between your Docker container and your orchestrator instance. And this will keep continuing. But the problem here is, like I said, these logs do not last after you shut down your container, right? And therefore, if you want to save these logs, you can save them to a text file to inspect later. But you can also save these logs persistently to your disk, to your host machine. We'll take a look at that when we talk about volumes. And that is the reason why I am not going to cover this part of the documentation. If you come back to the UiPath documentation, you will see this line here. Of course, you can run it, but the problem is, without understanding what this line does, I don't think there's a point in simply executing it without understanding what's going on. So I'm going to reserve that for a later video. Now we are in the concluding section of the part 2 video. I had split this video up into two parts, part 2A and 2B, given the number of topics covered in part 2 as a whole, right? So in this section, I would like to highlight a couple of issues that you might run into during the course of working with UiPath Linux Robots. As I stated in the intro section of part A of this video, these may be something that you may never run into, right? But it will be good to know and keep an eye out for. Back when I set up Docker and my Linux robots infrastructure, the Docker environment supported the .NET 5 framework, right? We saw that when we inspected the Docker container in the earlier part of this video. And here it is. And then going further back into part A of this video, I had stated that the cross-platform automations are compiled as DLLs, right? Dynamic link libraries. And here's what the contents of our demo automation package look like when opened up in the NuGet Package Explorer utility. And sure enough, the package contents indicate that it has been indeed compiled against the .NET 5 framework, right? And here you can see that the demo project that was demonstrated in this video has been compiled into dynamic link library. Therefore, around the time I built all of this stuff, right, my Docker container supported the .NET 5 framework, and the automation was also compiled against the .NET 5 framework, right? So everything works well, just as you saw in the demo earlier in this video, right? So what's the issue, right? What is the issue? Here's the version of my studio today, right? I had left it on the preview channel, and I remember that at least one studio update patch got installed on this preview channel, right? So as of that date, right, 1/25/2022, the Studio version red 2022.1.0 beta, right? This is the version that you see on your screen. But then as I started building new Linux automations and deployed them, they began to fail. Any automation that I deployed and ran failed. And all these failures were the result of this error. And the message states that the recent project that I built, for example, this demo Linux receiver, is not compatible with .NET 5, right? Because it supports .NET 6. So you can see something changed. So what I did was I went back and opened up my most recently compiled package in the NuGet package explorer. And here it is. It has been compiled to .NET Framework version 6. We can see why this failure is happening, right? The official Docker container supports .NET 5, but the automations have advanced and they're being built and compiled against .NET version 6. And I did confirm that this update happened. And any automation I build today, right, those automations will be compiled against the .NET 6 framework. And this is the reason why I have not only shared the XAML file of the project that I demonstrated to you, but I have also shared the compiled package of this demo project with you, right? That way, if you notice that your projects in Studio are compiled against .NET 6 and are failing, and you still want to run at least one demo project in your .NET 5 compatible Docker container, then what you can do is you can upload this package straight away into your orchestrator tenant and then try to run it in your Docker container. That way, at least you will be able to get one demo automation to run to get a feel of how Linux robots work. So what is the solution to this problem? The last time I checked, I know that a Docker image supporting the .NET 6 framework is going to be released soon. I don't know when. And if it's already released, then I would suggest you bring everything up to .NET 6 compatibility levels so that you can build and run your automations in your Docker containers that support the .NET 6 framework, and also your automation packages that are compiled against the .NET 6. So this is one issue that you might run into when you are working with UiPath Linux Robots. Now comes the second problem. When Docker Desktop for Windows is running on your machine, there is also a utility that is running in the background. And that utility is named Virtual Machine Memory. And this utility comes up when you start Docker. What this utility does is it's in the business of managing memory when Docker is running on your system. This screenshot you see is about an hour old. And you can look at the state of affairs. I've had it run almost up to 94% memory and literally brought my machine to its knees. And this is something that you might want to look out for because it literally bogs your machine down. You wouldn't even know it until you start a few major programs side by side along with Docker Desktop for Windows. And this is an issue that has been reported by other users too. And the easiest remedy for this issue is for you to shut down your Docker installation when you don't need it. And once you shut down Docker Desktop for Windows, you will see that this utility here, this VMM utility, will also shut down within a few minutes of shutting down Docker Desktop for Windows. Again, this might not happen to you, but it's a good thing to keep an eye out for because you don't want your machine to be dragged down when working with Docker and other major software like UiPath Studio or Visual Studio Code. And this is why I shut down my Docker Desktop for Windows when I'm not using it, right? And I start it on my machine only when I need it. And so this brings us to the end of the part 2 of working with UiPath Linux Robots. I hope that between the part A and part B of this video, you have learned something new. And if you did, please do like and subscribe to my channel. Thank you and bye.